All right, I think I fixed everything to record. Just to let you know, they've got to take my iPad back in, but I took it for today so that I could use it to teach. But you can see here that something's wrong with the digitizer. It's not letting me. One of my entire screen is blank in one spot, so it's still messed up, so it's going back in the shop today, so it might be another while till I get my iPad again, but I'm able to use it today. And we're going to talk again, we're just talking about initial value problems, something that's not going to be too complicated for today. Again, we're not really solving differential equations yet. We're not really going from the derivative back to the potential solution. What we're doing is we're given the solution, and we're going to determine, okay, what's the specific or unique solution to the initial value that they give us. And so you worked with this in Calc 1 and Calc 2, where we'll go ahead and look at example 1. Like, we have y prime is equal to 2x, and if I wanted to find the solution to that differential equation, here we would integrate both sides, but here we should already know it's going to be y squared equals x squared plus c. And that plus c, so what we have is a solution, but it's a family of solutions because we don't know what that value of c is. That c could have been 0, and we could have just stayed with x squared, or that value could be 5. And so what happens is we're going to be given an initial value so that we can find that particular solution to our differential equation based on the initial value that they give us. And so we're just going to work on the initial value, on initial value problems. They're going to give us initial value. We're just going to solve for C. All right. So again, today's not going to be a day that's going to be really new to you. So what we're going to do is we're just going to find, okay, well, we know that this is the differential, or not the this is the solution to the differential equation. What we want to do is we want to solve for that C. So how we do that is we're just going to plug in for our x and our y, our value. So that's, y of, here you can see x sub 0. So what's in parentheses is the x. What's not in the parentheses, what's it equal to? That's going to be your y. And so we're going to go ahead and plug in. So we're plugging into our function y equals x squared plus c, but we're going to substitute in our point. X is 0, y is 0. So we know that 0 is equal to 0 squared. Let me fix that. I'm having to write differently on this as well, just because of how everything's messed up. All right, so 0 is equal to 0 squared plus c. Well, that's just going to be 0 is equal to c. So that means that, our function, our solution is just y equals x squared based off of the initial value that they give us. Again, if they gave us a different initial value, we could have a different, a different answer for our solution because our c is going to be different. So here you just have, how based on the initial value, all of these, dash marks or all these lines, they're all solutions to the differential equation. All right, but we're looking for, okay, what's the differential equation that's going to go through, this exact point? And so that's why, that there would be our solution. All the other ones are potential solutions, but since based off of the initial value, that's why, what's in blue in the top right, that's why that's the solution. All right, second order initial value problems where you just have the initial values for not only your function, the original function, but also for the first derivative. And so over here you see you have values for that first derivative y prime. And so not only are you looking for the solution, but you're based off of initial value, but you also have the slope, what y sub 1 is, it has to go through, and that's where that initial value for your derivative comes into play. So let's go ahead and look at example 2. We're going to find c, and so we have y equals 1 x squared plus c is a one parameter family of solutions. One parameter meaning, one, c that we have to solve for. The first order differential equation, y prime plus 2xy squared equals 0. So they already give us the solution. We're told that y equals 1 over x squared plus c is a solution. So we don't have to find it. All we need to do is find a solution of the first order initial value problem consisting of this differential equation in the given initial condition. And we want to get the largest interval I over which the solution is defined. All right, so we're already told that y equals 1 over x squared plus c is a solution, so that's already taken care of. And now what we're going to do is we're going to substitute in our x value is going to be negative 2, and our y value is going to be 1/2. That's 1/2. So I'm just going to go ahead and plug in. So we have 1/2 is equal to 1 over x squared plus c. Oops, forgot to substitute in for x. And our x is negative 2. All right, so we're going to get 1/2 is equal to 1 over negative 2 squared is 4 plus c. Cross multiply, we're told that 4, or we see that 4 plus c is equal to 2. Solve for c, subtract 4 to both sides, so c is equal to negative 2. So therefore, our solution is going to be y equals 1 over x squared minus 2. And now all we have to do is determine, okay, what's the interval? What's the domain of this function? All right, and so our interval, I'm just going to scoot up again because there's parts on this iPad I can't write on. Well, you know, x is not allowed to be negative 2, plus or minus negative 2. That's the domain. X is not allowed to be plus or minus the square root of 2. Because if that's the case, we're going to get 0. So we have intervals from negative infinity to negative square root of 2 over 2. And just negative square root of 2. Another interval between negative radical 2 and radical 2. And then another interval between radical 2 and infinity. So really, it tells us to pick the largest interval. So we're not going to pick the middle interval. That's not, you know, the largest. And then you have two choices. You could pick negative infinity to negative radical 2 or radical 2 to infinity. Either one of those are okay because those are the, you know, both going to be the largest ones because they both go off to negative infinity. All right, that's it for the first bit.